Welcome to lesson 4.6, Interpreting Circle Graphs. So now we've learned all the different parts of a circle, we've learned different formulas to find area of a circle, circumference of a circle, and so now we're going to apply what we've learned about circles to not only learn how to draw, but also interpret a new type of graph. And that's a circle graph. So this lesson, our focus is to interpret circle graphs to solve different problems. So most of you are already probably somewhat familiar, at least, with what a circle graph is or what it looks like. Sometimes they're called pie charts or pie graphs, but we're going to call them circle graphs. And it's just another way, another visual way to represent information in some way. So we're going to actually get started just on the next slide here with an example before we move on to the lesson kind of component of this section. So I'm looking on page 156 of your textbook if you want to follow along with me, but we're just going to start with a question. And I'm just going to prompt you with a few questions as we read through this example, just so you can start thinking in your head about the usefulness and the application of circle graphs. So in a nutshell, this question says that some students at a school were surveyed to find out what their favorite after-school activity was, and then the results are depicted in a circle graph. So down here we can see that this is the example of a circle graph based off of the question in the example, which was, what is your favorite after-school activity? And so we can see, okay, well, I'm just going to ask you some questions about what you see actually. So just based off of our circle graph, which activity is the most popular? And how do you know? And which activity is the least popular? And how do you know? So hopefully just by looking at the graph, you can say, okay, well, I can just see that the biggest kind of piece of the graph that's represented with a color is this pink. So I would know that hanging out with friends is probably the activity that is the most popular, and I can confirm that by looking at this percentage over here, that 30% is the highest percentage out of each one represented. On the other hand, the least popular, I look and right away I notice that this orange piece is the smallest piece that's represented by a color, and I can confirm that by looking at the percentage, which is only 5%, and that's the smallest percentage out of each one. So I know that reading would be the least popular activity for students after school. So that being said, I just want you to think to yourself, was this circle graph, was it useful in answering those two questions and giving you that information really quickly about what was the most popular and the least popular activity just by looking at the graph, not having to calculate anything, not having to do anything, just by looking at it. So personally, I found it really easy because it's represented in a very visual way, so that information is really easy to find right away. And so my next question to you is, and I don't know if you can necessarily solve this right now, but we'll talk about going into how you solve it. But by looking at this graph, would you be able to come up with a strategy or a way to figure out how many students, so I want a number of students, prefer each type of after-school activity? So I'm not looking for a percentage, I'm looking for a number. So how many students prefer each type of after-school activity? So by looking at my graph, I know that 30% of my total number of students like hanging out with friends. I know that 25% enjoy playing video games, 10% doing homework, only 5% reading, 10% watch TV, and 20% are playing sports. But I want to know, what does that equate to in a number? Because that's kind of the important information. So I need to ask myself, what is my total number of students, or what is my whole, what is my 100%? And that takes us back up to the question where I read and it says 60 grade 7 students. So I know that my total number of students that I'm looking at is 60. And so if I'm asking you how many students prefer each type of after-school activity, we need to draw on what we learned last unit with fractions, decimals, and percentages to figure this out. So essentially, if I wanted to figure out how many kids specifically enjoy hanging out with their friends, I would need to solve and figure out what is 30% of 60. And if you recall, we learned how to do that last unit with fractions, decimals, and percents. Likewise, down here, I would need to figure out what is 25% of 60. Same thing here. What is 10% of 60? I guess that applies for both of those questions, and so on for all of them. Actually, let's just go ahead and solve this question while we're at it, and because it's here, just so we can follow through and see with how you solve it. So if you recall back to the last unit, if we're figuring out a percentage of a number, you change your percentage to its decimal form. So I'm trying to figure out what is 30% of 60, so I would change my 30% into a decimal, which is 0.3, and then multiply by 60. And when I do that, I get 18. So this 18 represents the number of grade 7 students that prefer hanging out with friends after school. Let's do this one. Playing video games. If I want to figure out the specific number of students that play video games, I need to figure out what is 25% of 60. How do I do that? I change my percentage into a decimal, which is 0.25, and I multiply by 60. And that gives me 15. So I know that 15 students prefer playing video games after school. If I'm looking at doing homework, 10% of 60, 10% is a decimal, 0.1, multiplied by 60, that gives me 6. So I know that 6 students preferred doing homework, and I also know that 6 students preferred watching TV because that represents 10%. In terms of reading and playing sports, I actually don't even have to do any math. If I look at this, I'm just going to do some mental math in my head. If I know that 10% represents 6 students, 5% is half of 10, right? 5 is half of 10. So 5% is half of 10%. If I know that 6 students represents 10%, I just need to half this number, and it will tell me what 5%. So half of 6 is 3, so I know that 3 students represents my 5%. Thinking in opposite terms, 20%. 20 is double 10, or 10 times 2. So again, I don't even necessarily need to even do the math here. All I need to do is take my number of students that represents the 10%, which is 6, and double it, and that will represent my 20%. So 6 times 2 is 12. So I know that 12 students enjoy playing sports as their after-school activity. And I just bring this up because this mental math component with fractions, decimals, and percents is kind of important because as you move through math, you want to be picking up on those little tips and those tricks that make things easier for you so you're not making more work for yourself. And so just on that same kind of note, a little bit of a side note, if I had just started with my 10% here, I could have figured out pretty much all of these just by starting with my 10%. So if I know, again, just to double check my work too, if I know that 6 students represents my 10%, what is the relationship between 10% and 30%? I know that 30% is 3 times 10%, or 10 times 3. So if I'm just double checking my work, doing some mental math here, if I know that 10% is represented by 6 students, I would just need to multiply this 6 by 3, and that would tell me what my 30% is. So is my work right? 6 times 3 is 18, and I can see that I was correct in the first place. So again, that mental math part of it makes cuts down your workload and just makes things a little bit easier. And when we can get to that stage where we're starting to think a little bit more abstractly about numbers, that's where we want you to be. But if you're not quite there yet, of course, you can always write out and show all of your work for each of the questions. And if I just wanted to take one last step to confirm that all of my work was right, what would I do? And how would I verify my solution? Because that's always important to do. So if I know that 60 represents my whole, or my 100% of my circle graph, I could take all of my numbers that I figured out, or the specific numbers of students. So I have 18, 15, 6, 3, 6, and 12. And if I was to add all of those numbers up, all of those numbers should equal to 60. So if I add 18 plus 12 plus 6 plus 3 plus 6 plus 15, that gives me 60. So I know that all my math was correct and I verified my solution. Because 60 represents the whole, or the 100%. So now that we've gone over one example of how you kind of interpret and collect data from a circle graph, let's just talk about the really specific details of what a circle graph is and what it needs. So here I've just plopped in a picture of a circle graph and its different components that are necessary for an effective circle graph. So in a circle graph, data is shown as parts of a whole. So our whole, or our 100%, is represented by the circle, and the number or the value for that whole will change depending on the question. So in our last example, our whole, the value of that was 60 because that was the total number of students that were surveyed. This might be a different value for that whole because it's a different question. So favorite sports of grade 7 students. That whole would depend on how many students were surveyed. But all you need to know is that data is represented in different sectors that represent a value compared to the whole. And so the whole circle, I'm just going to write this down, the whole circle represents 100%. And each of these individual sectors of the circle, they also represent a percent. So if you can see, this one's a little bit fuzzy here, but each sector of the circle is also given a percentage. So 27%, 20, 24, 13, and 16. And so all of those sectors, they have to add up to 100%. So I'm just going to write that here. So your sectors add up to 100%. Because it wouldn't make sense if they added to anything else, knowing that our whole circle has to have a value of 100%. So what sort of other things does a circle graph need to have? A circle graph needs to have, let me just get a different color here, needs to have a title. So we've done a little bit of graphing in the past and in previous units, and graphs always need to have a title. I need to know what kind of information am I looking at. If it doesn't have a title, those numbers are useless to me, and I don't know what they represent. So it should have a title telling me very clearly what data is being presented in your circle graph. Okay, so next, so what else does a circle graph have? A circle graph, each sector, so each piece of our circle graph, is assigned a category, and usually those categories are color-coded. So you have to tell me not only the percentage that each sector represents, that's very important, but you also need to tell me what category does that sector represent, and typically it's color-coded. So here we can see that our orange sector, the category is basketball. We see that our green sector is also, oh, sorry, I misread that. Our orange sector is baseball, our green sector is basketball, our purple sector is football, pink is hockey, and blue is soccer. So you need to give me a percentage for each sector, and you need to tell us what category each sector represents. And you can represent those categories in, I guess, one of two ways. So the way that it is done here is you can make a legend. So we can see that this is called a legend. So it's just telling us what each of those sectors represents. Or you saw in the last slide, the last circle graph that we were looking at, that each of the sectors were labeled kind of directly with their percentage. So instead of it being in a legend, it might just have a little arrow pointing to that sector, and it would be labeled football, and then it would have its percentage out here, so 24%. So you can label those sectors in two different ways, either using a legend or kind of labeling it right on the circle graph. So let's look at one more example together, and then that will be the end of the lesson, and you can start working on your practice questions for this section. So the example we're going to look at says, this graph shows Nathan's typical day. Which activity does Nathan do about 1/4 of the time, and about how many hours does Nathan spend on each activity? And then it wants you to just check that your answers are reasonable, which we should be getting into the habit of always doing. So first, just by looking at the graph, what can you see first off? So I can see that he sleeps a large chunk of his day, which most of us probably do. School takes up a pretty big proportion. Recreational activities looks almost equal to me as school, and then homework and eating are kind of the smaller portions of his day. So the first question, A, so which activity does Nathan do about 1/4 of the time? So this 1/4 is the important piece here. What do we know about 1/4? What does that represent as a fraction? Well, I guess we know as a fraction, or as a decimal, and as a percentage. Because that will help us figure out our numbers are represented in percentages in our pie graph. So we kind of need to know what 1/4 is as a percentage to help us solve this part of the question. So if you recall back to last unit with fractions, decimals, and percentages, 1/4, if I wanted to figure out the decimal, I hope this is one now that is just starting to come naturally. This is one of those really common ones. If you don't, remember we go our numerator divided by our denominator, so 1 divided by 4 gives us a decimal of 0.25, which is equal to 25%. So if I look at my circle graph, I say which of those activities is close to 25%, and that will tell me what he does about 1/4 of the time. And I see that he does recreational activities for 22% of his day, and that he's at school for 22% of his day. So what does he do about 1/4 of his time? I'd say he's at school, or he's doing recreational activities for 1/4 of his day. So just thinking a little bit further about that question, if Nathan is at school for 1/4 of his day, and he's doing recreational activities for about 1/4 of his day, that means for about half of his day, he's doing both of those things. So half of his day is taken up by school and recreational activities. That was just extending my thinking just a little bit and showing a little bit of a deeper understanding about the relationship between those fractions and the decimals and percents and how they work together. So let's move on to the second question, B. So about how many hours does Nathan spend on each activity? So we see that he spends 22% of his time doing recreational activities in school, he spends 40% of his time sleeping, and 8% of his time doing homework and eating. So if you think back to the first example we did at the very beginning of this lesson, we need to know what the whole represents in order to figure out these numbers. So if we're thinking in terms of a day, what is 100% of our day? What is that as a value or as a number? So one day is characterized by 24 hours. So our 24 in this example is the value of our whole, or the value of our 100%, because that's what these numbers are being compared to. He spends 40% of his 24 hours sleeping. He spends 22% of his 24 hours at school and doing recreational activities. He spends 8% of his 24 hours eating and doing homework. So our 24 hours is our 100%, or is our whole in this situation. So now that we know what our whole is, we can move on and start finding the specific numbers the specific amount of hours that he spends doing each of these things. So if we think back to the first example, if I was to find out how many hours does he spend a day sleeping, I know he spends 40% of his day sleeping, so I would need to find out what is 40% of 24 hours. And so how do I do that? So I have to change my percentage into a decimal, which is 0.4, multiply it by 24, and that gives me 9.6. And because we like to kind of think of hours in terms of whole numbers, we're just going to round this. So 9.6, I'm going to round up to 10 hours because that's the closest whole number. Remember, because this 6 is higher or is greater than 5, we round up. If that 6 was 4, 3, 2, or 1, we would round down. So because it's higher, we're going to round up. So I can say that Nathan spends about 10 hours a day sleeping. That's a lot of sleep. I wish I got 10 hours of sleep every day. So let's do the second one, 22%. So what does 22% represent as a number? So we need to find out what is 22% of 24 hours. I changed my 22% into a decimal, 0.22, multiply by 24, and that gives me 5.28. And again, we're going to round this to a whole number. I'm going to look at the number in my 10th spot, and I see that it's lower than 5, so it's a 4, 3, 2, or 1, so I'm going to round this down, and I'm going to keep it at 5 hours. So 22% of his day is represented by 5 hours. So he spends about 5 hours at school, and he also spends about 5 hours doing recreational activities a day. And so the last one we need to figure out is what that 8% represents. So we need to figure out 8% of 24 hours. 8% is a decimal, 0.08. Multiply that by 24. And that gives us 1.92. And again, let's round this. This 9 is greater than 5, so I'm going to round it up. So he spends about 2 hours of his day eating and about 2 hours of his day doing homework. And if I wanted to verify my solution, just to make sure that my answer is reasonable, I could do one of two things, I guess, in this situation. I could take my hours. So I have 2, 5, where else are we? 5, 10. Am I missing one? 1, 2, 3, 4. Oh, and another 2 here. And if I was to add those all up, what should it equal? Or be very, very close to being equaling? 24 hours, because that represents our whole. So 10 added to 5, 5, that's 20, and then we have our 2 1 hours, so that's 24. So we know that this is reasonable because all of our answers, even though we've rounded, 5 plus 2 plus 2 plus 10 plus 5, that equals up to our whole, which is 24, so that's reasonable. I guess the other option you could do was to take your decimal answers before we rounded, so our 9.6, 5.28, I guess we would have 5.28 twice, and we would have 1.92 twice. If we were to add up all of those should equal 24, because again, that's our whole, and that represents our value of our 100%. So if you have any questions, please bring them to class. Otherwise, you can get started on the practice questions for this section. Thanks for listening.